Next, we deal with the serviceability requirements. The question asks us to evaluate the design against the serviceability requirements, such as the maximum and the minimum bar areas. The equations for the minimum bar area is this. You will need FCTM, B, D, and FYK. The BD represents the size of the beam. From the structural key plan, the B is equals to 200. As for the effective depth, it is equals to 402, which we have calculated it while designing for the tension reinforcement. As for the FCTM, you may refer to table 3.1 in Eurocode 2. FCTM can be determined based on the concrete grade. The concrete grade for the beam is 30 Newton per mm square. Referring to the table, the FCTM is equals to 2.9. Alternatively, you may use the equations given in table 3.1 to calculate the FCTM. There are two equations here. When the concrete grade is less than 50, you may use this equation. Coming back to this question, your FCTM is equal to 2.9. FCK is given in the questions, which is equals to 500. Substitute the value, you get your AS mean equals to 121. This represents the minimum areas that you need to provide for the beam. Check your provided area against the minimum bar area. Previously, we have calculated the provided area is 942. The provided area is more than the AS mean, therefore it is considered acceptable. As for the AS maximum, it will be equals to the 4% of the cross-sectional area of the beam. The beam size is 200 times 450. Multiply with 4%, you get 3,600. The AS provided is 942, which is less than the AS maximum. Now your AS provided is more than the minimum and less than the maximum. Therefore, the proposed design is considered acceptable. Next, you are asked to check for the minimum bar spacing. The minimum bar spacing, it will be determined by three factors here. It shall be greater than the maximum bar size, at least larger than 20 mm, and it should be at least the maximum size of the aggregate plus 5 mm. The purpose of having the minimum bar spacing is to ensure the concrete flow around the reinforcement during the construction. Coming back to this question, the bar size used based on the design is H20. For normal concrete, the maximum aggregate size it will be 20 mm. Aggregate size plus 5 mm, that gives you 25 mm. Consider these three factors here. At least 20 mm, at least the size of the bar, and at least the size of the maximum aggregate size plus 5 mm. You know that you need a minimum spacing of 25 mm. Next step is for you to calculate the actual spacing between the reinforcement. Based on the reinforcement bar design, you will need 3 H20 bars as the tension steel bar at the mid-spec. That gives you this arrangement of the reinforcement bar as the bottom reinforcement. When there are 3 reinforcement bars arranged together, your actual spacing it will be between the bars. Assuming the center reinforcement is placed in the symmetrical manner, In order to calculate the spacing here, you will use the width of the beam minus 2 cover minus 2 shielding minus 3 bar size and divided by 2. The concrete cover is given 30 mm. The shielding is given in the questions R8 and H20 bars are being used. This gives you the actual spacing 32 mm. The provided spacing is larger than the required spacing. Therefore, the minimum bar spacing is considered passed. Next, the question asks you to check for the deflection. To be more precise, you are checking the limiting L per D ratio. The equations you may refer to clause 7.4.2 in the Eurocode 2. There are 2 equations here. First, you will need to check which equation is to be used. These are the conditions for the equation by comparing the row against the row note. The row represents the percentage of the reinforcement provided, and the row note is given by this equation. Based on the definitions given by the Eurocode, the row refers to the required tension reinforcement ratio. That means when you want to calculate the row here, you will use AS required instead of AS provided. AS required is the area of the reinforcement as calculated required by the beam section, whereas AS provided, it will be the amount of reinforcement bar that you have actually provided. Since it is clearly stated in the Eurocode, you will use the AS required, which is equals to 844 in this question. And then the B and D, the B is the width of the beam, 200 mm, and the D we have calculated earlier on, which is 402. That gives you the row here. As for the row note, you need FCK. FCK is 30 as given in the question. Then you obtain the value for the row note. Compare the row and the row note. The row is greater than the row note. When the row is greater than the row note, you're going to use this. In the equation here, you need row note, and also row prime. Row prime represents the required compression's reinforcement bar. If you look at your previous calculation step, as given in the previous videos, the K is less than 0.167. That means no compression bar is required. When there is no required compression bar, the row prime will be equals to 0. And then in the equations, there is a K. This is a factor for you to determine the limiting L per D ratio. You may obtain the K from table 7.4n in Eurocode 2. The K value is depending on the type of the element. The beam that you are designing is the end span beam. For the end span of the continuous beam, the K will be equals to 1.3. Having all the value ready, substitute into the equation, you get your L per D ratio equals to 19.9, and then there will be some corrections factors. There are 3 conditions that you may have the correction factors. First, It is when the span is more than 7 meters. In this case, your beam span is only 5.6 meters, which is less than 7 meters. Therefore, there shouldn't be any correction factors for the beam span. The second correction factors is about the reinforcement. When the specified yield strength of the reinforcement is not equals to 500 Newton per mm square, there will be corrections factor. In this case, the FYK used is 500 Newton per mm square. That means there is no corrections factors for the specified yield strength. Next, there will be corrections factors due to the amount of reinforcement provided. The AS required is 844, whereas the AS provided is 942. Your AS provided is slightly larger than the AS required. Therefore, there will be corrections factor, which is equals to the ratio of the AS provided by the AS required. You take the 942 divided by 844. That gives you 1.12. This value need to be checked against the maximum allowable ratio here, which cannot be greater than 1.5. If the calculated factor here is more than 1.5, you will use 1.5 as the factor. Now it is time for you to compute the limiting L per D ratio. Your calculated L per D ratio, 19.9, is to be multiplied with factor 1, multiply 1, and multiply 1.12 as the multiplications factors, and then you get your limiting L per D ratios 22.3. Next, you will need to find the actual L per D ratio. The L refers to the beam span, which is 5.6 meters, whereas the D is the effective depth of the beam, which is 402 mm. Divide the L by the effective depth, you get 13.9. Your actual L per D ratio now is less than the limiting L per D ratio. That means the deflections is acceptable. This question asks you to check for the serviceability requirements against these three items, namely the maximum and minimum rebar, minimum bar spacing, and allowable deflection. There are other serviceability requirements such as the maximum spacing, maximum bar size, surface reinforcement, side face reinforcement, and others. For a typical beam, especially when the cross-sectional area is relatively small, maximum bar spacing is not an issue. You will have issue with minimum bar spacing. That's why the questions for the beam normally will ask you about the minimum bar spacing. The side face reinforcement normally deals with deep beams. The purpose is to control the cracking on the surface of the beam. Now in this example, the height of the beam is only 450. The beam is not really a deep beam. Therefore, the side face reinforcement will not be an issue. As for the surface reinforcement, it deals with spalling of concrete, especially when the axis distance is relatively large, which is more than 70 mm, or when the bars is greater than 40 mm diameter. That means the surface reinforcement for the beam in the question is also not an issue. The concrete cover is only 30 mm, not really thick, and the bar size provided is only 20 mm. not greater than 40 mm diameter. Therefore, the risk of spoiling is not high. With that, you do not really need surface reinforcement. This provides you an overview for the serviceability requirements. While trying to solve the example questions, we also discuss a bit other things as a part of the revisions to you.